Hearty welcome to the viewers. Happy in continuing the video lecture after 2 years. And again, thank the viewers for the continuous support and encouragement. In the and presently, I am working as a practicing structural. I have been a professor for a long time, and now I am practicing as a structural consultant in Sakti Civil and Structural Consultancy Private Limited. We have opened a Coimbatore regional office, which is located in Vadavalli and Coimbatore. Vadavalli, Coimbatore. Right. Now, this is lecture number, is a continuation of my video lecture. This is lecture number actually 129, second part of 128. And we will discuss on static indeterminacy of structures. At this juncture, I want to thank the authorities of PSG Tech, so who have made me popular in this video lecture by giving all facilities, encouragement, and support. It's my duty to thank them. Right now, coming to this lecture, in the last lecture 128, we have discussed about the basics of equations of equilibrium, reaction components, degrees of freedom, etc., which I don't want to repeat, but I'll just rush through. So this is a hinged support, two reaction components and 1 degree of freedom. Roller support, there is 1 degree of 2 degrees of freedom and one support reaction. Fixed support, there are 3 reaction components and no freedom. This we have discussed, and we have discussed about the basic conditions of equilibrium. When a structure cannot be analyzed by using only these 3 conditions of equilibrium, we call the structure statically indeterminate structure. If a structure cannot be analyzed only by using these 3 conditions of equilibrium, we call a structure as a statically indeterminate structure. And we are dealing with the two-dimensional structures. Right. So in the last lecture, we have discussed beams and portal frames. Now in this lecture, we'll take up pin-jointed trusses. Now pin-jointed trusses, the members of a pin-jointed truss can take only tension or compression, axial force only. It is capable of taking shear force, but it is not capable of taking a bending moment because they are connected by means of hinges. But shear force is not considered because the forces in the trusses are transmitted only through the joints. Therefore, we consider only axial force, namely tension or compression only. The truss will never get loaded in between the members. It is that the loads are assumed to be transmitted only through the joints, and the members are assumed to be connected by pin joints only. This is what we assume. Even though the reality is different, we make these assumptions, and only with these assumptions we just proceed. Right now, let us take trusses. Now here, a truss, as I told earlier, a truss may be internally redundant or externally redundant. Redundant means, internally means having more number of members than that are required for its stability. If a structure can be stable with the 4 members, in that place, if you provide one more member, then naturally it is indeterminate. It cannot be analyzed by using the basic conditions of equilibrium alone. But there is a procedure for analyzing indeterminate structure. Now, that is about internal indeterminacy, having more number of members than what is required for the stability of the given truss. A truss may be externally indeterminate. Externally indeterminate means, suppose if a truss has more number of supports, if it is resting on a continuous support, namely, say 3 hinges, let us say 3 hinges. Now we know each hinge can take 2 reaction components. 3 hinges means there will be 6 reaction components. We have only 3 equations of equilibrium. Therefore, with 3 equations of equilibrium, 6 unknowns cannot be solved. Therefore, the structure will be externally indeterminate to 3 degrees. But a structure can be both internally indeterminate as well as externally indeterminate. That is, it can have more number of members and also more number of support reactions, etc. Right. Now, the truss shown in the figure A is internally indeterminate. That is, it has got one extra member. We'll discuss how to find out the degree of indeterminacy. This has got one extra diagonal member. Then what is required? If it is of simple triangles, if it consists of simple triangles like this, we can easily identify. Of course, once you practice 1 or 2 cases, you will come to this conclusion. So this is determinate, internally determinate. That is, it has got just a sufficient number of members. Formula is there, we will discuss. Right. Now here, this is externally determinate. Externally, you have got a hinge here, you have got a roller support here. So there will be 2 reaction components in a hinge. There will be 1 reaction component in a roller. So 2 plus 1, 3. 3 equations of equilibrium. So externally it is determinate. Internally it has got 1 member. So it is internally indeterminate. Externally determinate. Right? So externally it can be analyzed only using the 3 conditions of equilibrium. Right. Now the second truss B, is resting on 2 hinges. So each hinge can offer 2 reaction components. Therefore, 2 plus 2, 4 reaction components. We have got only 3 equations of equilibrium. Therefore, it cannot be analyzed directly. So, it is externally indeterminate, internally determinate. Right. Now, coming to the procedure. This is discussing only about internal indeterminacy. Yes. We can make use of this formula, I equal to M. The truss has to satisfy this condition. M equal to 2j minus 3. Number of members, M stands for the number of members, J stands for the number of joints. So M equal to 2j minus 3. So when we want to find out the degree of indeterminacy, that is internal indeterminacy, number of members connecting, number of members and number of joints. M equal to 2j minus 3, or we can say I equal to, say, this is the formula that is used, I, that I stands for internal indeterminacy. I stands internal indeterminacy equal to M minus 2j minus 3. If the number of members and number of joints satisfy this equation, it is called statically determinate. Otherwise, it will be either deficient. If the number of members are less than 2j minus 3, the truss will be deficient. The truss will not be stable. If it has got more number of members, then it is indeterminate. II equal to that. Suppose if the truss starts from a rigid joint instead of starting from a hinged support, roller support, etc. If it starts from a rigid support, then the formula will be I equal to M minus 2j only. That also we are going to discuss. M minus 2j minus. Right. Now, there are some cases. Now, let us take the first example. Say, the first example, see, all the 4, A, B, C, D, all are resting on one hinged support and one roller support. Hinged support, roller support, like this. So all the 4 examples that is given here are externally determinate. So there are 3 reaction components, 3 equations you can solve. Coming to internal indeterminacy, right? Now, this truss has got a member, one member, two, three, four, five, and six members. There are six members. M equal to 6. Coming to joints, pin joints, 1, 2, 3, and 4. There are 4 joints. Now, coming to this table, example A, we have got 6 members. There are 4 joints. 4 joints means 2j minus 3. That is 2 into 4 minus 3 equal to 5. 8 minus 3 equal to 5. Therefore, M minus 2j minus 3 equal to 6 minus 5 equal to 1. So, this truss has got 1 degree of internal indeterminacy. If one member can be removed without this member or without this member, any one member, if any one member is removed, the truss will be stable. So with this diagonal, it will be stable. So this diagonal is extra. So 1 degree indeterminate, 1 degree redundant. So and now coming to this truss, on seeing the truss after some time, on seeing the truss, you will be able to identify whether it's a determinate truss or indeterminate truss. Now this is not consisting of basic triangles. So you got one diagonal member that is required, one more member is extra. So this is redundant. Not only this, any member can be removed and the structure can be made determinate. Right, one extra member. On this side also there is one extra member. So there are two members. So this structure is internally indeterminate to 2 degrees. Right. Coming to the systematic procedure, and now joins 1, 2, 3, 4, 5, 6. There are 6 joins. 6 joints. See for B, there are 6 joints. 6 joints. So 2j minus 3 equal to 2 into 6 minus 3 equal to 9. 9. Coming to number of members, we have got one vertical member, two horizontal members, 3, 4, 5, 6, then two diagonal members, 6, 8, 9, another two diagonal members, 11. There are 11 members in the truss. There are 11 members in the truss. Therefore, M equal to 11. Already we have got 2j minus 3 as 9. So 11 minus 9 equal to 2. So this structure is 2 degrees indeterminate. So similarly for other structures, simply we have to count the number of members. Say we'll 1, 2, 3, 4, 5, 6, 7, 8. Like that we can just count and find out the number of members, number of joints. From this formula I equal to M minus 2j minus 3. So we need not discuss every case. Right, that is the procedure. Now, here these trusses are internally indeterminate, externally determinate. Right, a truss can be both externally as well as internally indeterminate. So combination of internal and external redundancies. Actually, this case we have not discussed here. We are discussing only about the internal indeterminacy. So this we have skipped, therefore that is not necessary. So right now, coming to this truss, right. Now this is one another important case. Now this truss starts from a rigid base. So the formula is I equal to M minus 2j only. This same truss here it starts from a simple base, that is a hinged support and a roller support. Now for this the formula I equal to M minus 2j minus 3 is to be used. Now when the truss starts from a rigid base, this 7 need not be considered for the calculation. It is a rigid support. 7 need not be considered as a member. So there are only 6 members. So 1, 2, 3, 4, 5, 6 as numbered. 7 need not be counted. Now here all the 7 members are to be considered. The formula here is I equal to M minus 2j only. Here it is I equal to M minus 2j minus 3. Right, that is the formula. Right. In the first case, there are 6 members only. There are 5 joints. again, coming to the joint, so 6 members and 5 joints, even without considering these 2 joints, we can just calculate. Anyway, that I will come to this point little later. M equal to 7 equal to 2 into 5 minus 3. 2 into 5 minus 3. Right. Now for this stress, there are 7 members. 1, 2, 3, 4, 5 joints. 5 joints. The formula applicable is I equal to m minus 2j minus 3. Therefore, 7 members, 2 into 5 joints minus 3 equal to 0. This is the static indeterminacy. Actually, it is a determinate truss. Now, coming to this truss, I equal to m minus 2j. That formula is better. Yes, I equal to m minus 2j only. So, I equal to m minus 2j. That is not here. Now, 2 joints. 1, 2, 3 joints. Actually, here we got 3 joints. There are 6 members. As I told, this need not be considered. There are 6 members, 3 joints. M minus 2j equal to 6 minus 2 into 3 equal to 0. So this is determinate. This is also determinate. All consisting of only basic triangles. It is determinate. Right. Now coming to this stress. Now this stress has got 4 supports, 2 hinged supports and 2 roller supports. So this stress is externally indeterminate because 2 reaction components here, 2 here and here. There are totally 6 reaction components. Only 3 equations of equilibrium. So externally it is R equal to R is the number of possible reaction components. In this case, R equal to 6, small r equal to 6. Capital R is the number of conditioned equations available is only 3. Therefore, 6 minus 3 equal to 3 is the degree of external redundancy. Coming to internal redundancy, there are 4 joints. 1, 2, 3, 4. There are 4 joints. 5 members. So m minus 2j minus 3 will be equal to, m is 5. 2j minus 3 is equal to 2 into 4 minus 3. That is also 5 equal to 0. So this stress is externally indeterminate to 3 degrees, internally determinate. So with this basics, let us go through some examples available in the form of a table. Right. Now, here m equal to 5. There are 5 members, 4 outside members and 1 diagonal member. There are 4 joints. So 1, 2, 3 and 4. There are 4 joints. So m minus 2j minus 3 equal to 0. Coming to external redundancy, small r stands for the number of reaction components possible, that is 2 plus 1 equal to 3. Capital R stands for the number of equilibrium equations available, that is also 3 equal to 3. So that is also equal to 0. I stands for internal indeterminacy. IE stands for external redundancy. So this is 0, this is 0. So totally the structure is statically determinate. Right. Now this is another example. Only thing is the support is on this side. That's all. Same example. And coming to this stress, example 3. Now, one hinge here, another hinge, another roller support. So we know that 2 plus 2 plus 1 reaction, totally small r equal to 5. There are 5 reaction components. Right. We have got 3 equations of equilibrium. Therefore, 5 minus 3 equal to 2. Right. Coming to internal indeterminacy, we have got 4 outside members, 2 diagonal members. So sometimes students used to confuse this as a joint and all these as members. Please avoid. It is a crossing of 2 diagonal members. members. That's all. Crossing of two diagonal members. Therefore, this is not a joint, and this is a member from here to here. So that confusion need not be there. So there are 6 members, 4 joints, 4 joints. So M equal to 6. M equal to 6. J equal to 4. 4. Therefore, 6 minus 2 into 4 minus 3 equal to 1. So this truss has got 1 extra member and 2 extra reactions. So internally indeterminate to 1 degree, externally into 2 degrees. So total degree of indeterminacy equal to II. I stands for internal indeterminacy. IE stands for external indeterminacy. So different books will use different notations. One thing I forgot to inform you that this is a material taken from our own book. Written a book. Myself, my senior author, and my guide, Dr. Vaidyanathan, myself, and one more author. We have published a book, Structural Analysis, Volume 3. So we have taken this material directly from that book, right? So II and IE equal to 1 plus 2 equal to 3, right? And so this is again, we can find out internally it is 1 degree, externally it is also 1 degree because 2 hinges, 2 plus 2, 4 reactions. So R equal to 4, capital R equal to 3 equal to 1. 1 plus 1 equal to 2 degrees indeterminate. Totally it is 2 degrees indeterminate. Right, now coming to this truss, it starts from a simple base. So 2 plus 1, 3 reaction components. We got 3 equations of equilibrium. Therefore, external indeterminacy equal to 0. Coming to internal indeterminacy, we got 7 members as we discussed earlier. There are 7 members, 5 joints. 1, 2, 3, 4, 5. 5 members. Therefore, members, joints 5. 5 joints. 7 members. So 7 minus 2 into 5 minus 3 equal to 0. Internally determinate. So it is indeterminate to 0 degrees, both internal and external. Totally it is a statically determinate structure. Now coming to this stress, you have to understand the difference between the two cases. So here it starts from a rigid base. Therefore, this need not be considered as a member. Joints 1, 2, 3 only. We need not bother about these 2 joints. So considering these as joints also, we got a procedure. Let us avoid confusion, right? So as far as vertical support is concerned, either the joint or the member need not be considered. So you got 1, 2, 3, 4, 5, 6 members. Coming to joints, pin joints 1, 2 and 3 joints only. Therefore, I equal to M minus 2J only because it starts from a rigid base. So M minus 2J equal to 6 minus 2 into 3 equal to 0. Therefore, this stress is internally determinate and externally also determinate. So this is a very important point to be noted in the examination or answering the questions of somebody. So both are determinate only. Right. Again starts from a rigid base. Therefore, 3 joints. 1, 2, 3 joints only. Coming to members, 1, 2, 2 diagonal members, 3, 4, 5, 6, 7. There are 7 members. Coming to joints, 1, 2 and 3 pin joints only. It starts from a rigid base. Therefore, II equal to M minus 2J. So M7 minus 2J, it is 1. So now you can easily understand that when you got one extra diagonal member other than a basic triangle, you can easily identify whether the truss is determinate or indeterminate. I equal to 1, E equal to 0. So totally it is 1 degree indeterminate. Same thing, the numbers are to be counted. That's all. Numbers are to be counted. Externally it is determinate because 1 hinge and 1 reaction. Internally there are 11 members. There are 6 joints. 1, 2, 3, 4, 5, 6. So equal to 2, because you got one extra diagonal member here, one more extra diagonal member here, I equal to 2. So that is how you can. Now coming to the next case. Now it starts from a rigid base. Coming to joints, this is the only pin joint, only one joint. So j equal to 1. Number of members 5. 1, 2, 3, 4, 5. 5 members. I equal to internal indeterminacy equal to m minus 2j. M number of 5 minus 2 into j equal to 1. So it is statically indeterminate to 3 degrees. 3 degrees. Externally it is determinate. So 3 degrees internally indeterminate. Right. Now coming to this. There are 4 members. Same example. One member less. That's all. M equal to 4, j equal to 1, m minus 2j. So that is equal to 2. Now here let us discuss. Suppose there are only 3 members. There are only 3 members. M will become 3, j will become 1. So it will become 3 minus 2 equal to 1. 3 minus 2 equal to 1 with 3 members. 3 members it is 1. With 2 members, m equal to 2 minus 2j equal to 0. So with 2 members, the truss will be stable. When the joint is rigid, 2 members are required for the stability of the truss. Third member extra, fourth member etc. extra, and fifth member also extra. With the 2, when a joint is rigid, with the 2 members and a pin joint, the truss will be stable, capable of taking loads. Right, that we have to. Now coming to this, one more example. Say 1, 2, 3, 4, 5, 6 external, and 7, 8, 9. There are 9 members. M equal to 9. M equal. And j equal to 1, 2, 3, 4, 5, 6 joints. 6 joints. So j equal to 6. I equal to m minus 2j minus 3 equal to 0. It is a determinate truss. It is a determinate truss. All consists of basic triangles only. And externally also it is determinate because there is a hinge, there is a roller. So that is about finding out the degree of static indeterminacy, both external as well as internal in the case of two-dimensional trusses. Now coming to space trusses, of course we will not elaborately discuss, we will just introduce. Now in the case of three-dimensional trusses, here it consists of 4 joints. This is at a higher elevation, this is at the base, all these 3 members, this is at a higher elevation. So it consists of 4 joints and 6 members, 1, 2, 3, 4, 5 and 6 members. So the formula to be used here is I equal to m minus 3j minus 6. 3j minus 6. So earlier it was I equal to m minus 2j minus 3. Now 3j minus. This is the formula that is used for the space trusses. Because here we have got, earlier we have used sigma x equal to 0, sigma y equal to 0, horizontal and vertical. Now you have to use sigma z is also equal to 0. We have used only one m value, sigma mx, now sigma my and sigma z. There are 6 equations of equilibrium in the case of space trusses. So that is, therefore the formula here is I equal to m minus 3j minus 6. So using the formula, if m equal to 3j minus 6, it is a determinate and a stable space truss. If m is less than 3j minus 6, it is a deficient truss and unstable truss. If m is more than 3j minus 6, it is a redundant truss. So this is the formula that is to be used for the case of space trusses. Right, we will not discuss all these things. Right, now before winding up, we will take another few minutes The portal frames, you can find out the degree of indeterminacy by either counting the number of reaction components minus 3. That is one method. Another method is number of closed loops into 3 minus number of releases. There is another method called tree analogy. Tree analogy method is a fairly hassle-free way of doing redundancy. But what we simply do is, I'll just simply explain. Right. Now what we are going to do is, we are going to convert the given frame into number of trees. A tree is rooted to the ground. It will not move in the x direction, will not move in the y direction, and also it will not rotate. There are 3 reaction components. Now, as long as this branch is not connected to any other branch, or this branch is not connected to the ground, as long as it is free, as long as any number of branches, so it is a cantilever. A cantilever is a tree, or a tree is a cantilever. It is not connected to other branches or to the ground again. It is determinate. So what we are going to do is, we are going to convert it as a number of trees. For converting it as a number of trees, we have to give number of cuts. In one occasion, I told you, if a member AC is cut at the point B, in the earlier lecture 128, we have discussed, if a member is cut at a point B, we are removing the capability of taking an axial force, capability of taking a shear force, capability of taking a moment. So 3 releases we are giving. So that is the concept we are going to follow here. Now, instead of taking this example, this simple example, we will take another case for tree example. Now I will come to this a little later. Right now, let us take a portal frame. 3-story portal frame, single bay, 3-story portal frame. Earlier, what we have done is, number of closed loops is 1, 2, and 3. Closed loops into 3. 3 into 3, 9, minus number of releases. No release here, no release here. Therefore, I equal to 9. That was the formula that we have used earlier. Number of closed loops into 3 minus number of releases. Now coming to this, we just give a cut here. By giving a cut here, we are removing the axial force carrying capacity, shear force carrying capacity, and also moment. It becomes a free end. Right. Therefore, we are giving 3 releases. That is why minus 3. 3 releases. So here also minus 3. Here also minus 3. So we are giving 9 releases for making the structure as 2 cantilevers. 2 cantilevers. So I equal to 9. Now coming to this, we are giving 2 cuts. So this is a cantilever with 1 branch. This is a cantilever with 2 branches. This is a cantilever with 1 branch. So we have made it as 3 cantilevers by giving 2 cuts, or by releasing 6 reaction components, internal force components, Therefore, I equal to 6. Earlier, number of closed loop is 2 into 3 minus no release here, minus no release here. Therefore, I equal to 6. So both coincides. Right? Now coming to this. So 1, 2, 3, 4, 5. 5 closed loops into 3, 15. No release. All are fixed ends. So 15 is the degree of indeterminacy. By tree analogy, we get minus 3, minus 3, minus 3, minus 3, minus 3. So we have converted this as 4 trees. This is a tree with the 2 branches. Here also 2 branches. Anyway, as long as it is not connected to some other branch, or as long as it is not connected to the ground, it is a cantilever. It's a cantilever. There are 4 cantilevers for which you give 5 cuts, I equal to 15. So that is another method of finding out the degree of indeterminacy by means of tree analogy. So that is for two-dimensional plane frames. So now in this lecture, we have discussed how to find out the degree of indeterminacy, both internal and external in the case of trusses, and how to find out the degree of indeterminacy of portal frames, two-dimensional portal frames by using tree analogy. So next we will take up a degree of static or kinematic indeterminacy of structures. That is in the lecture number 130 next. Right. So thank you viewers. Thank you. Thank you for your patience. Thank you.